What's up, everyone? This is Trey from Puertas Pythons. Today we're going to be talking about genetics and what you could expect from when you put your males in with your females, what different color variations you might get, if you're trying to make something, how to make it. So today we're going to be talking a little bit about that. So yeah, let's get started. Before trying to understand the genetics, a term we use in the repticulture, or herp culture, as I should say, is morphs. Now there are different types of morphs, which basically mean just different colorways of in particular species. Corn snakes have morphs, western hognose, ball pythons, boa constrictors. There's all different types of morphs or colorways out there. In ball pythons, we refer to those colorways as morphs, as well as do all different types of reptile species. Now in genetics, there are three traits. In genetics, there's the dominants, there's the codominants, and there's the recessives. We're going to first be talking about the dominant trait in ball pythons, which the first one we could talk about is a pinstripe. Now this is a dominant trait, meaning if you were to breed this, let's say with a normal ball python, theoretically you should get 50% pinstripe, 50% normals, because they're both dominant in the sense. And all of these different colorways and mutations lots of times come from imported snakes from Africa, where they originally are found. And you could get different colors, and breeders back then used to see these different colors and put them back to normals and see if they could reproduce this pattern or this color. So this is a dominant gene. If I were to breed this, let's say, to a spider, which is another dominant mutation, you would get 25% would look like the pinstripe, 25% would look like the spider, and 25% would be spinners, which is the combination of the pinstripe and the spider, and also 25% will be normals. So yeah, that's what the dominant gene does to a ball python. So basically you're going to express this gene in the babies. Now another thing that's a little bit more confusing than the dominant gene is the codominant gene, and that's where it can get a little bit more confusing. Now basically a codominant gene is an incomplete dominant, which meaning if you get a codominant gene and you breed it back to that codominant gene, it's going to create, it's called like a super form or a complete dominant. And I'm going to show you, first example I have is this pastel mahogany het clown. Now the het clown will come later into the recessive. We're just talking about codominant. So this snake right here has a double codominant, which is the pastel and the mahogany are both codominant mutations, but they're expressing themselves as the incomplete dominant form. So you're seeing just the mahogany and the pastel together. Now you could breed this to, let's say, a pastel and make super pastel mahoganies, or you could breed this to a mahogany and make super mahogany pastels, or you could breed another pastel mahogany and get super pastel super mahoganies. So basically the incomplete dominant of this, to make a dominant form, you would breed it back to that same color mutation. So for a pastel, you would breed it back to a pastel to make the super form. And I do have a super form, which you could kind of see a little bit better in this guy right here. This is my super pastel orange dream acid. Now the acid is a dominant gene like the pinstripe. The super pastel is shown here, not in the single form but in the double form. So this is a pastel bred back to a pastel to make this dominant form. So everything he will make, since he is the complete dominant now and he's the dominant gene, everything, the least he can make is a pastel once I breed it back to a normal. Then you'll have some orange dream in there, you'll have some acid in there, and you'll have a variety of different snakes, different colors coming from him. But the lowest thing he can make is a pastel because of the complete dominant once you breed them back together. Now we're going to talk about a little bit of recessive. mutations. But before we get into that, let's just look at a couple snakes. Now in the beginning, when I started breeding ball pythons, the recessive gene, trying to understand that was a little bit complicated. But we're gonna get through this now. This is my female clown. She's a recessive trait. This is my pastel clown female, actually. Now, basically, if you were to breed this snake with a normal, 50% of the babies will come out looking like normals, looking like pastels, and 100% of them will carry the gene of clown, but you won't see it in the visual form. And you can see this with my pastel het clown female. So this female right here just looks like a normal pastel. You can't see the clown in her, but she carries the gene for clown, so she has the opportunity to produce more clowns. And that's what I'm hoping for her this year. I'm breeding my NG clown to her, hopefully to make some pastel NG clowns. Now, basically what the recessive gene does, when you breed two recessives together, since it's basically almost like the dominant gene in a way, when you breed them both together, all you'll make is that whatever recessive gene you have. For example, if you were to breed a clown to a clown, let's take my banana killer blade clown and my pastel clown. If I breed them together, all my babies will be clowns because you're breeding two recessive mutations together. Now, if you were to breed, let's say, a het, for instance, het clown to a visual clown, theoretically 50% should be visual clowns and 50% should be het clowns. And you have the potential also, if you were to get a male het clown, let's say to her, actually, let's grab my male right here, my pastel mahogany het clown. This carries the gene for clown, she carries the gene for clown. If I were to breed them both together, I have basically, let's say if they were both normal het clowns, I have a 25% chance of producing a visual clown, 50% chance to produce the het clowns, but you can't see the het clowns because it's basically almost like a hidden gene inside of them, and 25% of them will be normals. That's if I were to breed a normal het clown to another normal het clown. So basically, the clown gene is a little bit complicated to understand, but once you get it down, it's super easy. And that's the way I would go for any new breeders out there. If you're trying to get into the ball python industry, stick with the recessive genes, because in the long run, they're going to hold their value much more than co-dominant and dominant genes because they are more difficult to reproduce. Not difficult in the sense of breeding, but it takes longer to get the end result. Especially if you're starting off, let's say, with one visual recessive male and you're breeding to a whole bunch of co-doms and let's say normals. All you're going to get is het clowns. You're not going to get that visual product until you raise those babies up and breed them back together to get the visual product. So recessive genes are definitely the way to go in any new ball python breeder out there that wants to get into them. But that's a little bit about genetics. I hope you guys learned at least something. Another website that helped me a lot from the beginning was World of Ball Pythons. You go under their genetic wizard. You can type in the male that you want to look up. Like, let's say you have a pastel clown male and you want to breed it to a clown female. You could type in the father, you could type in the mother, and press calculate. And it'll calculate the odds of what potentially you could make with those two breedings. So I highly suggest you guys check that out just to learn a little bit more about genetics. That's how I learned years ago, and now I'm fairly good with understanding genetics. But I hope you guys enjoyed this video. Make sure you guys hit that like button, subscribe to my page, and make sure you guys share this video with as many people as possible. Like I said, at 250 subscribers, we're going to do a giveaway. Once we get closer to that number, I'm going to determine, probably I'll do a vote of what the giveaway should be on my Instagram page. And if you guys aren't following that, it's Poeiras, Poeirs_pythons. And I'll leave it in the link down below. But yeah, I hope you guys have a wonderful day or night or whatever time of day it is where you guys are. And yeah, I'll see you on the next one.